Yeah, hello, you're welcome to the first class in this series. So this learning lab one, and I'm going to be taking you on this. And if you look at the screen properly, you're going to see the topic. The topic is actually training and evaluating a binary classification model. And let's get to it quickly. Now, what's in store for you in this particular class? So if you look at the other side of the screen, you're going to see the six things we are going to do in this class, and that's setting up a development environment, importing Python packages, loading data sets, data processing and feature engineering, then training the model and evaluating the model. So just check out for those things. So because we're going to do these six things today, and if you just follow me carefully, you'll be able to do all those things. Whether you have done this before, that say you have an experience, or you're just a beginner, you can still be able to do all those things. Now, how do we go about setting up an environment? For us to set up an environment, there are certain things we need to get. So I call them the tools you need for your development. One of them is Anaconda. Anaconda is not a complex thing to know about. If you want to access Anaconda, all you need to do is you go to Google, just type Anaconda into the search bar, okay, and then you're going to see this thing exactly. That's Anaconda Unleash AI Innovation and Value, and then you just click on that. It's going to open this particular web page to you. So when you get to this web page, you can then go ahead, navigate to this, and click on this free download. So depending on what your machine is, by machine I'm making reference to your laptop. Maybe you have a very nice laptop, say it's a Mac or Windows, depending on that. So you're going to see an option right here. You see additional installers. This for Windows, Mac, and Linux. So I don't know the one you're using. So, but you can just go ahead, click on download, okay, and select exactly the one you need. So once you do that, it's going to download Anaconda into your system. Anaconda is a very heavy software, so it's going to take up some space. It takes time to download and it's going to take space. So just click on this download and let's see. So you click on download, it brings you into somewhere in your own. It leads you to a directory in your local machine in your system. You select the right folder, you can create a new folder for it and go ahead and download. Okay. So as you can see right there, I'm downloading actually for Windows 64. Yes. But I will not download this now because I have it already. Do you understand? So, but for you, you need to download this if you do not have it. Now, when you do that, I don't know if you have an experience setting up a software, but it doesn't take time. You just go ahead, click on that software in your in your download folder, click on it wherever it is in your folder, and then just follow the installation steps, read the installation properly, follow the installation steps, and then you have it to your PC. I'm going to drop a link to a YouTube video on how to go about that in the group channel, that's in the Telegram channel. So just watch out for that. Now, the next you need also is some persons try to make a choice between using just Anaconda as their own development tool, right? But I prefer VS Code. Okay, there are options still. We have PyCharm, we have VS Code. Okay, Anaconda tries to bring up all the software you need for machine learning, data science, but it all depends. What do you really need? Okay, I also do make use of VS Code. VS Code is a development environment. Okay, so it's open source. You can, when you have your Python interpreters installed, and you can also install Jupyter Notebook in the VS Code, and you can use it to both do the normal experimentation, and also you can use it to build scripts and the rest. So I like VS Code, but I make use of this. I have three actually. I make use of PyCharm, VS Code, and Anaconda. But currently, I spend most times using just VS Code and not Anaconda. But it's good that you have VS Code, okay, and Anaconda. If you really want to like do more within the career, you just don't want to do a basic thing. You want to go for having the both of them will not cost you much other than just data. Now, if you've done that, this one is still is also simple. You just click on download, and it's going to lead you to make options. Do you want to download for Windows, or you want to download for you want to download the Linux version of it? Is it Linux, Debian, or Ubuntu? Or do you want to download the Red Hat, Fedora, to say, or you are using a Mac? It all depends. So if you're making use of a Mac, you need to select this. If it's Linux, you're making use of a Linux operating system, you select that. And then if you're making use of Windows 10 or Windows 11, you go ahead and select that part of it. And once you've done that, you can do everything we're doing in this class. Now, I'm still going to put up a video on how to download this. In case it's confusing to you, check the Telegram channel. I will drop a video and you can use that video to find your way. Now that we've done that, let me continue with this. So the next thing I want to teach you now is what are we going to do in this class? Now that we want to train a binary, we want to train and evaluate a binary classification model. What do we really need? Now we already know about the softwares we need. What about the packages we need? What about the packages that I need? What about the packages I need? Now let me talk about the packages I need. For us to do this effectively, we need this thing. For us to do this effectively, we need certain package. Okay, we need NumPy, we need pandas, we need scikit-learn, and then also we need matplotlib and plotly. So those packages, when we get to the part of doing the real work, you are going to watch me use them, okay? But just have a head knowledge of it right now. We need pandas, we need NumPy, we need scikit-learn, we also need plotly and matplotlib. Now, if we have those things, plotly and matplotlib is for visualization. The pandas and NumPy, we make use of that for data manipulation. They are just Python packages for data manipulation. The scikit-learn, that's also going to make use of during um, during model training and model evaluation stage. So when we want to train the model, we're going to make use of scikit-learn. Then also we're going to make use of scikit-learn for model evaluation, where we try to know what's the accuracy of our model, how effective is our model in actually meeting up with the task. So I hope you understand already. Now, uh, as we are as we take this our data through the packages, there's something that's going to happen, which I want to mention right now, and that's about the machine learning or data, yes, machine learning model development or the data science flow. What are we just going to do exactly? Now, what we're going to do is this: we're going to get a data that meets with the is it the target now, what we actually want to do, what's our objective in this class. We want to train a binary classification model. So the particular project we want to do, is there a data available for it? When we get the data, we're going to study the data, okay? And when we're done studying the data, we're going to select a target. The target is what do we really want? And then the features are actually variables, okay, that can help us get that desired outcome. So if you have a good understanding of just linear equations, okay, basic mathematics, the it's the y is the this thing, the dependent variable, and x the independent variable. So just know that the features are the independent variables, and then the y is the dependent variable. Y is the target, x are the features. Okay, so we're going to make use of the features, train the model with the features and target, and using those features we can then be able to predict future targets. That's just the basics of supervised learning. So I'll get the data, clean the data, try to process the data, try to perform feature engineering on the data. And when I'm done performing feature engineering on the data, I'll go ahead to use the data to train the model. When I'm done training the model, then I will evaluate the model. Let me repeat myself. We source the data, we clean the data, we then train the model. Okay, we clean the data, we perform feature engineering on the data, we train a model, okay, with the data, and then we evaluate the model. That's just it. So the rest we are going to know more about them when I when we continue the class. So let me hide this for now. So let's get started. Now that you have actually installed, I want to assume that you already have your Anaconda installed, and then also you have this thing installed. I want to assume you have your Anaconda installed, and then also that you have your VS Code installed. The next thing you would like to do is you want to get your hands dirty. So let's just get our hands dirty. Let's get started with something. Now, here's what I want you to do that most persons do not really advise one to do. When you want to build this kind of stuff, please open a project folder. Go to your system, open a new project folder. Don't just start that way. Open a folder. So you open the folder, then download the data in the folder. So let me show you right away how to go about this. So you go ahead and so right now, what I want you to do is navigate, go to your laptop or your desktop. Okay, so go to downloads or document, just wherever you want to create a folder there. When you're done creating your folder there, here's the next thing we are going to do. So once you've created a folder, the next thing you need to do is in the first part of this video, I'm going to make use of um, Anaconda. So I'm trying to get it started. So here's what you have to do. Let me show you my Anaconda. When you click on Anaconda, this is what you're going to have. Let me briefly. So go to your desktop. Now that you've opened the project folder, click on Anaconda. When you click on Anaconda, Anaconda is going to open up. When it opens up, let's check. Very soon it's okay. So we will show you the Anaconda as I navigate through it. Okay. Hmm. Okay. So now it's up in my PC. So let me show you the anaconda. Okay. Yep. Now just look at the screen right now. You're going to see. So this is it. When you put an anaconda, this is what you're going to have. So you're going to have this exactly. And if you're just a first user, you might need to download, install before you launch. But for me, I have PyCharm and all these ones installed already. So I don't need to install. I can just launch immediately. But for you right now, you might need to install some of them. So when I have this, I will just click on, okay, there are things we'll later get to know about how to set up this app, base route and the rest. But for now, just use the base. The base is actually a global, that's where you install packages, and the packages will be installed globally in your system. But if you now know about environment management, it means that you're making use of just environment. But you'll learn these things in my class, in the future class. So for now, let's just click on launch. Just do the basic thing. Click on launch Jupyter Notebook. When you click on launch Jupyter Notebook, it's going to take a little time, depending on the kind of system you're using. For me, it's going to take me a little time, and then it's going to make the notebook available to me. Okay, it's taking much time now than I expected. Okay. So while I wait for that, I don't know why it's giving me a little ish now. Let me just, what's going on? Okay, it's taking much time actually. I don't know why. Maybe because my system has been on for a while and I just force closed Jupyter Notebook. I don't really know the exact reason, but then let me believe it's what's going on. What's going on exactly? So while I wait for that, let's just have a little music. Okay, yes. Now I clicked on launch and guess what? It worked. Okay, so it worked. Now I can actually see the Jupyter notebook in my Windows. So I'm going to switch the presentation to the Windows part of it so you can see the Jupyter notebook right now. I can't really say what happened, but then just something happened, okay? Right now I have the Jupyter notebook in my, yeah, that's it. So I have it somewhere now. So you can see. So whenever you click on launch, it's going to lead you to this. So as you can see, the Jupyter notebook, it's on a local host, and then the tree is bringing up my folder structure, like all the folders in my PC. And then actually, I instructed you to create a folder. So depending on on the location of the folder you created, the location of the directory, that's going to determine the next step. For me, the folder I'm making use of in this particular project, it's in this place in is in documents. So when I click on documents, go to, for me, I'll just go to churn if I'm right. Okay, no, let's take it back. It's right under OneDrive. When I click on OneDrive, I'll then go to documents. Okay, I'll go to churn. So it's good you know how to navigate your folder. When I go to churn, that's where I have everything that I need. Okay, the all that I need to work on this project, I have them right here. So if you are just starting out, you can then go ahead. Now, this is one thing I want you to do for me. Now that you've created a new folder and you've opened a Jupyter notebook, click on new. Click on new. Can you see new there? You just click on it. Select Python 3 IPY kernel. When you do that, you will have a new, it will do this exactly. Now you have a brand new Jupyter notebook to do your experimentations, okay? Now the next thing you need to do, if you've not done that already, is to download the data set that you need. Now, before going ahead to download data sets, let me give you a little introduction to the project we want to do. This project is all about churn. So I want to build a machine learning model that will help me to predict if a customer is going to churn or not. What is churn all about? Here's an overview, a very fast one. Churn, churn meaning in business. Let me select that. So what's churn all about? So it is the measure of how many customers stop using a product. It can be measured based on actual usage or fail to renew. So let's say you're running a subscription-based service where customers choose your service and maybe they say we're going to be in your service for a month, or you have a yearly subscription plan, or you have a 6 month subscription plan. So that's it. So if the customer at the end stops using your service within the tenure, or before the tenure is completed, or immediately after the tenure completes, it's completed, it means the customer has churned, right? The customer is no more using your service. So this model is all about determining if a customer is going to leave the service or not. That's what we want to do. So it's called a churn prediction model. Now, for us to do this, we need a data set that allows us to do that. We need to go online and search for a data set that, okay, has to do with a subscription business and contains information, okay, about the customer, if the customer churned or not. Okay, that is just the data set we need. And for us to do that, we need to search Kaggle. Now, Kaggle is a good place where you can get data sets. Like, there are a lot of sites where you get data sets, and Kaggle is one of them. You get a good number of data sets from this place to build your machine learning model. So if you want to really go to that, okay, start this thing, you can just type Kaggle, just type Kaggle, churn prediction. I believe if you type Kaggle and churn dataset, it will bring you to this telecom customer churn. That's the one I want to use here. And you click on that, it's going to take you to this exactly. You will have this. So if you open Kaggle newly, they will not allow you to download dataset unless you create an account. So you just sign up, create a free account with Kaggle, and then Here is the data set we want to make use of. This one in particular, telecom churn prediction, customer churn. Each row represents a customer. Each column contains customers' attributes described in column metadata. What do we mean by that? You search the column metadata, you will find information about these things. Now, this is it. This is what we're talking about. Okay, it's just a little overview of what. Okay, this is the metadata: customer ID, agenda, whether the customer is a male or female, senior citizen, partner, dependent, tenor, phone service, multiple lines. So all those things are features, and it has 21 columns. The last column tries to tell us if the customer churned or not. Okay, so that's just exactly what we need. And I'm going to, for us to download this, I'll just click on this. When you click on download, it's going to come into your PC as a CSV file. Yes, a CSV file. Now, what you have to do for me now is you need to navigate to that folder you created for this project, the folder where you opened your Jupyter notebook. You have to navigate to that folder and download this data set into that folder. It makes it very easy to work. Okay, if you download the data set in another folder, you will need to make use of a particular command that enables you to search global wide, that's globally, for data set. But to save yourself the stress as a beginner, please ensure you download this data set into that folder you created where you have your Jupyter notebook. If you have any question about this, remember you can ask me right there in the Telegram channel. I'm going to explain to you. And so you do, I have it already. I don't need to download. So I'll just close this. Now, if you look at this folder where I open my Jupyter notebook, you can see untitled. That's my new Jupyter notebook. Now, this is actually that data set, WAFN, USEC, telco customer churn, as a CSV file. It's there already. I just go ahead and do this thing and make use of it. I don't need to download it again. Now, now that you have this, we have started. Let me give you a better. Okay, I already defined what customer churn is, and we in this project we are going to do this. Let me use Escalidraw. What we want to achieve in this project is just this. We have this customer churn data set. We want to train a model. Now, when I get my data set, I'll have to clean this data set, and then I will clean and process the data set, use it to train an algorithm. When I train this algorithm, and the algorithm will now have an information. When it has an information, okay, I will then test the algorithm with a new set of data and watch it predict if the customers in this new set of data will churn or not. Then I'll evaluate the accuracy. It's as simple as that. Okay, now here are the now let's go ahead and start making use of the packages we need. Okay, so we need to import to work this project. We need to import pandas. We need to import pandas. We need to import numpy. Import numpy as np. Then I'm actually working with Python. This is a Python class. We also need to import matplotlib as np. Okay, so that's just it. We continue with the importation of packages. But because I want to make this class fast, we've already spent some time already. I will not do all those things manually. I will just copy from where I have it already, a source document, and once I copy that, I will just paste it there just because of time. Because of time, but I'm going to give you a good explanation of every. So here's what I'm going to do. I'm just going to do this copy and paste. So these are the packages I need. I will run. When I run this, it's going to import them into this Jupyter notebook. Now let's watch it get imported. Every one of them. Okay, that's it. So I have all of them right now in this Jupyter notebook. That means I can work with them. Now, for you, when you do this, it's possible that Plotly will give you an error. You hear that Plotly is not even in your system, or maybe something like Matplotlib. All you have to do whenever you encounter that is to manually install by clicking on pip install Plotly. That's just it. You don't need to stress yourself. Click on pip install Plotly. It's going to install it. Any package you do not have access to in your Jupyter notebook, it means you don't have it already in your system. And you can just go to Google and search how to install that package. For example, installing Plotly. Installing Plotly in Jupyter notebook. Just click on this, and then you will see the command you need to what you need to actually type to get it. So, and that's exactly what I did then. You see something like this. Where is it? Okay, it says, yeah, just do pip install package name, right? So when I do pip install Plotly, I will have that. It's as simple as that. That's just what you need to do. Now back to business, back to what we were doing initially. Now that I have all I need to work with, what's the next step? The next step is this. We need to now go ahead and load the data set into the we need to load the data set into the environment. So how do we load those things? I'm going to create this. I believe you have a basic knowledge of Python. If not, you watch out for a video I'm going to share on how to get started with Python. But just read the speed dot read CSV, okay, and then next it's the name of the data set itself, and this is the data set. So I'm just going to copy this, copy the name. Now since it's actually a name, it's a string variable. Maybe you do not know about the data structures in Python, but in Python we have strings, integers, floats, the likes of them. If you don't have a basic knowledge of Python before now, don't fret about it. Resources that will get you started will be made available in the Telegram channel. Both some videos and books you can actually go through and get the basics of Python. So this is just how to do it. I just installed the data set. So now that I have the data set, I can go ahead and view this data set. What do I mean by that? I can click on this. Now, when I click on df.head, PD stands for pandas. Now, pandas is a Python package that helps you to manage data sets. Now, pandas has two major data structures, and that's data frame and series. So when I say read CSV, my data structure now is actually um, a data frame. Okay, so when I click that dot head is actually uh, a property of data frames. That's a property. Python is about object-oriented programming. So every object has a property. For example, you as a human being, you have your color, you have your hair, and the likes of them. So just that same way, a data frame has properties. So dot head is a property of the data frame. When I click on this thing, it's going to bring up the first 10 the first 10 rows in that data set. So this is what the data set looks like. I have this, okay? The tech support, stream TV, the likes of them. Maybe you want to have a better view of the columns. You want to see the columns better. Here is something else you can actually do for me. Just come right here, add capital T, click this, okay? And then change this 10 to 21 since we have 21 columns. Here's what's going to do. It's going to turn this thing upside down, okay? So all the columns now become all the column heads that appear at the rows, like they become the beginning part of the rows. Yes, so it helps me to see all the columns at a time and also to understand the data that I have there. So you can see the customer ID, female, senior citizen, the likes of them. What is the churn? Did the customer churn? No. Did the customer churn in this category? Yes. Here, no. Here, yes. You can actually see their monthly charge. These are amounts they paid per month. Now you can see the total charge, and then also you get to see the tenor. Tenor refers to the duration. Where is that tenor again? Tenor actually refers to duration. So one, that's in months. The tenor is in months. So 34 months. That's what this stands for. It means that this person's tenor runs into this thing, into years, right? That, and if you check out the contract here, you have 1 year. So that means this person has been in the business for some years now. 12 months make a year. So we're talking about at least 2 years and almost 3 years, right? Almost 3 years. This person has been in the business, and the person did not churn. Definitely, that's a long-term customer. And some other customers that churned, you look at them here. This person, no. Okay, that means did the customer churn? Okay, yes, this person churned. The contract is month to month. What's the tenure like? To just 2 months. The person used the service for 2 months and stopped using it. Okay, and the person churned, paid a very high total charge, which is $108.15. This is the monthly charge. Now, as a data scientist, you have to really go ahead and study your data. But we don't have time for that now, okay? Because it takes some time. You need to really look at your data, try to understand it, even before you start working on it using Jupyter Notebook and the rest. You can actually open it in Excel, go through it, run a basic analysis. What's this all about? Okay, now, but the rest of it, we are going to do it within the class. Now, the next I'll do after that is I need to understand the shape of this data set. What's the shape like? What does it look like? So I'll just do df.shape. Good. And it tells me that we have this thing. We have 7,043 rows and 21 columns. 7,043 rows. That means all those things. I inverted it. I used transpose. T there stands for transpose. Let me put it there. T stands for transpose. So it means I have 7,043 rows and then 21 columns. That's what I have here. Next, I need to do df.info. Okay, dot info. Um, wait, let me make it a tuple. So this information I have right now. It means I have 21 total columns, 21 range in there, 7,043. We know that already. And then it also gives me an understanding of the data types right there. You can look at these data types and then even the memory usage. This thing is using 1.1 megabyte of my memory. That's the data itself. Okay, and then we have three major data types here: float, integer, and object. So I am going to do something. I'll try to understand the data type of each column. Is it really the appropriate thing? So for customer ID object, okay, text actually, if you know Python data structures, text are objects. It's allowed. Text are like strings, but if the data type of a text it's object, that's fine. You won't really see string among the data types. Gender objects, that's male or female, that's okay. Senior citizen integer, now that's 0 1, that's still okay, but we're going to do something about it. Partner objects, partner is yes or no, so all those yes or no's should come as objects. The numbers should come as float or integers. That's it. So that's what we're checking out for right now. Now you look at tenor. Tenor is integer. That's okay. The number we have here, monthly charge, float. That's okay. Total charge, object. Now that's a problem. We can't have total charge as object. And right here, I'm seeing numbers. It means there's a problem. We need to turn the total charge from numbers to. We need to turn it from numbers to what it should be. Okay, we need to turn it from object rather to what it should be. It should actually be a float or an integer. So that's the next thing I will do right now. The next thing I'm going to do is to bring up that needed conversion. That's exactly the next step. So we'll do this immediately. Let's paste this quickly. So here's the code I have here. Converting total charge from object to numeric data type. Then also converting numerical values. Okay, senior citizens, we'll do that right now. So when I click on this and click on run, it's going to run. For me, you can use run or you just do shift enter. Same thing. Hold shift enter. That's same thing as run. So when you do that, df total charge pd dot to underscore numeric. So what does that stand for? We want to convert all the data in total charge column. We want to convert it from object to numeric data type. Okay. To check if what we did worked, just click on df dot d type. Okay. And then okay. So click df.d types. You have this. So you look at this right now. Total charge has changed. In the past, the total charge was object. Right now, we have it as what? Float. So let's do the next thing. We need to work on another one. It's here. So I'll add this here. Click Shift Enter again or click on Run. So I will check the data types again. So you discover that right now for senior citizen, wait. Okay, good. Now, in the past, we had senior citizen as integer. Right now, senior citizen is object. What did we do? Now, the senior citizen column, you go to it, and we make use of dot apply. Now, dot apply is actually part of it's a Python this thing used, okay, to apply a function to a data set. So what this code is doing right now, it's lambda x. It's lambda x is also okay. It what it does here is this. It goes to that row and select x. So if x is if the let's go to senior citizen. If the thing is no, if x is equals to 0, okay, change it to no. That's what's going to do. So that means in place of all those things, what's it called? 0, 0, 0, 0. I want to see no, 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 no. And now if x is yes, if s is not 0, that's x is actually 1 or any other number, change it to yes. That's what the code does. Okay. Let me not bore you with the details of what dot apply is, lambda, this, that use cases. This is just a good use case. You just do this and you have it. You can do that for any other. Maybe you can go ahead and check, do a test. Try to do this for any column. You can select your own column, choice column, and do that. So let me show you what the data frame will look like right now. If I do df.t.transpose and I go for head 10, I'll have something that looks like this. So can you see now? Right now, I no longer have no, 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 the likes of them. Now I have yes, yes, yes. No, no more 0, 0, 0, 0. I have yes, 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 or 1, 1, 1, or something like that. Everything has changed, okay? Because I worked on that. So what I'm doing now is what we call data manipulation. I am beginning to manipulate the data in the data set. I'm changing them. My works is beginning to affect the original data set. So as I'm doing this, I'm carrying out data manipulation. I'm already affecting the data set. I'm trying to know the data set to correct it, to clean it. That's the job of a data scientist. As you are doing this already, you are already practicing. So that's why I say you get your hands dirty in the class. Get your hands very dirty. You are working on data sets already. After that, the next thing we get to do is this. We have to check for something. And then that was very, very important. We need to check for what we call null values. Null values. How do we check for null values? And what are null values? Now, no values refers to this thing. Okay, we're checking for no entries. Are there actually entries in the data set that's zero? Okay, are there cases in the data set where there is no value at all, where it is just zero, like empty, nothing there? Now that's what I just did. So to do that, you do df dot is null dot sum. Okay, the is null is that placed null. Okay, and then the dot sum helps you to sum up all the null values in a particular column. So I've done that already. Now if you look at the display, the output, you discover that in total charge we have the same, we have 11 null values. Now what's the total number of rows in this data set? 7,043. Now what do I have left? I have 11 that are null, that's empty. Okay, you don't just, so the next thing is, what am I going to do about the null values? You don't just go ahead and wipe them. No, you don't just go ahead and is it do, or there are techniques. My point is that there are actually techniques, okay, for handling null values. And this time around, I'm going to introduce you to another friendly tool a data scientist can make use of. Here is a very, very friendly tool you can make use of as a data scientist or a machine learning engineer. You will need to make use of ChatGPT. ChatGPT is awesome. Okay, and in the past, if you are doing programming or something like this, you just depend on Stack Overflow and Google. But right now with ChatGPT, you can also do a lot. You can do a lot. I think this where I ran. Okay, good. Yes. So I already did this. Good. Let me start a new thing with you. So let me say, I you are a data scientist running a project. So you're a data scientist running a project. How can you handle no values? I'm asking it a question. So it's going to give me techniques for handling no values. Yes. Okay. Now here, dropping the no values, imputation. Okay. We have forward field, backward field, linear regression, using k nearest neighbor and the likes of them. But take a note. Look at this. This is the simplest approach where you just remove the rows or columns with no values. However, this approach might lead to a loss of valuable data, especially if the data set is small or if the no values are prevalent. So for us, I'm just going to drop the no values actually. Why am I dropping the no values? Number one is because it's very, very small. Okay, compared to 7,043, just 11. Two, they are not so sensitive. It's not really going to affect my model, okay, for me. But you don't just drop those things. That's my point. You, depending on your domain knowledge, as it outlined here, okay, also you have to consider, yes, your domain knowledge. Those no values, should you forward fill them? Is it very, very important? You might need to consult somebody, okay, that has a domain knowledge to give you guidance. But for me, in this case, we're just going to drop them. So watch me drop those null values. Watch me drop them. For me to drop them, I'm going to use a particular function. I'm going to use this to drop it. Just so I will go ahead and do. So now that I dropped them, I just dropped all the no values. If you check this now, right now, you see that the total charge, no more no values, right? So it means my data set is okay. So if I go ahead and check for the shape now, everything has changed. It's no more 7,043. Now it's 7,032. Okay, because I removed some no values. I've reduced the number of rows. Yes, I just reduced the number of rows in this data set. So after this, what's the next thing I can do? Now that I've done the basic data manipulation, are there other things I need to do? Do I still need to manipulate my data further? Yes, okay, it's possible I need to do more. And the next line of code I'm going to paste, it's about that. Okay. Yes, so that's it. So here I have df.columns. When I click on df, remember I'm working with a data frame. When I click on df.columns, so df is a data frame, and then one of the objects of a data frame is columns. A data frame has rows and columns. So just the way you have df.columns, we also have df.rows. So when I click on df.columns and say equals to df.columns.string.lower, it means that all the rows, like all these columns now, I want all of them to appear, is it in lower letter, that's lower caps, lower alphabet. Here you have senior citizen in capital, citizen in capital. I want it to appear as senior citizen, just small letters, everything small letters. That's actually what it's going to do. Why do I need that? Within a short time, I'll be calling some of these rows and some of those columns. Okay, so I won't, while typing, I might make the mistake, instead of typing senior citizen, that's starting with S and then citizen with capital again, I might go ahead and type senior citizen just this way. Okay, and if I do this, guess what? I'll have an error. Okay, I must do it like this to really enable this thing to select that exact column. So to avoid all those problems, I want to turn this thing to look this way. I want it to become basic, just basic, okay, so that I won't make an error in typing. So I want to use lower. So let me explain this further. What this is going to do, df.columns will access all the columns. When it accesses all the columns, like the names on those columns, it will go ahead to the string. Now I talked about data structures. Words, letters are actually strings. So when it gets to the strings, it will now perform the lower operation. That's turning all the strings, okay, to lower letters. There's also dot string dot upper that will turn it towards capital letters. There's also dot string dot proper. So I mentioned dot lower, dot upper now, and also yes, dot proper. For me, I want to turn them to lower. Okay, that's small letters, everything. Now the next line of code, string columns is equals to list. Now list is part of data structures in Python. Okay, we have list. This is what a list looks like. A list is just a list. This way, imagine if you start this and I'm listing out things like orange, comma, things I need to buy, pawpaw, comma. Okay, that's a list. That's a list. So yeah, I believe you know this already. You have Python basics. So let me not spend so much time there. So list, so df types df, okay, equals to object dot index. So I just created a new this thing now. I listed out all the objects. By that I mean, you see, if you go to this place, all the columns, okay, that are actually objects like customer ID, gender, senior citizen, partner, dependent, phone service. By doing this, I've been able to select all of them, okay, as now to add this to all entries with space. So that's the next thing. So for call in string columns, df, what's this all about? What I'm doing right now is just let's view the data set now after doing that operation. df dot t dot head. Let's say the first 10. So take a look. In the past, I had this no phone service. Okay, right now look at what we have. Everything in small letters. Can you see the difference? Yes. Everything in what? Small letters compared to what we had here. Capital. The first operation tried changing everything to lower, right? Now the next operation tries to put this. Okay. So instead of just no phone service, this is what I have now. I have it this way. Instead of just fiber optic, I have it this way. So it's better. Why am I doing all these things? One, it's to allow me to make use of the data set better and also get it more ready for model development. So when I'm through with this, I I've not done all, but at least I've done the basic data manipulation. I've done the what? Basic data manipulation. I've done a lot. I've done what? A whole lot. And now, one of the things that might really take our time, which I won't do in this class, is to go into exploratory data analysis. I won't like to do that because it's going to take time. Yes. So, but we can do this. We can do this one. And I'm going to explain what this is all about. Good. Now, you look at this. Beginning of the class, we imported some packages, and I told you we're going to make use of them. One of them is Plotly. Plotly is an awesome tool. Let me quickly introduce you to Plotly. Now, Plotly is a very good tool for data visualization, one of the best so far, and it's better than Matplotlib because it offers you an interactive interface and the likes of them. So it's good you get started with Plotly. I'm going to introduce you to lots of them in our class. So the first I'm introducing you to now, it's Plotly. So here is what it's one of the things it does is this. You can actually get it's interactive. So check out this, check out what we did here. Okay. Now can you see? Now this is it. If I used this thing, um other tools like basic tools like Matplotlib or the likes of them to do this, I won't have this interactive display. But when I touch any ball here, it brings up an information. That's the advantage of Plotly. So what's this all about? PX is to call Plotly. Remember, I brought in Plotly, import Plotly Express as PX. So now, whenever I call PX, I'm calling Plotly Express. So now, Plotly Express has this thing. It has arguments or parameters I need to feed into it. One of those parameters is the data frame, which I already have there. The next is what should be on the x-axis, that's total charge. X-axis, total charge. Now you see, this is the reason why I turn the total charge, everything to be what in lower letters, that's smaller letters. Imagine me typing total charge. If I didn't do that, I have to type in my total charge as total, T capital, C capital. And I might run into some errors if I don't do the right thing. So when I change everything to lower, I'll have it this way. Okay, Y is the tenor. The color is churn. It means I want to differentiate my data by churn. Did the customer churn or not? And then facet code is contract, and that's this part of it. Trend line, OLS. So what does this do? Look at this place here. If it's blue, that means no churn. If it is red, churn, that's yes. So if I look at this, it tells me to see something that customers that had a month-to-month contract, they churned more. Most customers running on month-to-month contract, they stopped using this service. That's why you have majority of the churn. Then when you get to 1 year, we have just few churn. Okay. Now when you get to 2 year, very few. Most customers here didn't churn. They are still in the service. But you see those that subscribe to a month-to-month contract, they left. They didn't stay for long. But guess what? We also have more customers within this demography, more customers within that particular area. So that's all the visualization I'm going to do in this class. We'll not do more than this because of our time. Yes, I wouldn't like to do more than that because of time. Now, here's the next thing we can do. The next thing we can do here is okay, I'll change this to Markdown. So here we're going to work on feature engineering. Good. So what's feature engineering? Now that I've done the basic data manipulation, I've done the data clean, like I've cleaned the data set, removed all the no values, I've manipulated the data type, manipulated some data within the data set. That's data manipulation. I need to go ahead and do feature engineering. Now, feature engineering, it's there are two, there are actually two things about feature engineering. One is feature extraction, the other is feature selection. In feature engineering, we have two things. Let me use the escalator to show you that we have two things in feature engineering. We have um, feature selection, okay? Feature selection, and also we have feature extraction. So in feature selection, it means that we want to actually select the just the features that we need to work with. Okay, that's feature selection, and use that to train the model. In feature extraction, in feature extraction, I will have to manipulate. Okay, now feature selection is the process of selecting a subset of relevant features for use in model construction. Now, feature extraction, it creates new features from functions of the original features. Okay, so whereas feature selection just focus on this place, returns a subset of the features. So that's it. So those are the two techniques we make use of in feature engineering: the feature selection or the feature extraction. In feature selection, you are just going to take a subset of the relevant features. In feature extraction, you are manipulating, you are creating new features from those functions. So let me give you an example of feature extraction. For example, if I should join partner to dependent, yes, no, to form a new feature to train my model, that is feature extraction. But if I just select few this thing few just a few features from these 21 features I have here to train the model, that's called feature selection. So those are the two things we make use of in feature engineering. Okay, so now let's discover the one I'm going to make use of. You never can tell. Maybe from now you start guessing which one am I going to make use of. So let me start with this. Let me have this here, and then yeah, so convert the churn values okay from strings to integer, okay, to allow better categorical encoding. Now the code will create panda series of type boolean and convert it to integers. If the boolean corresponds to yes, the as type.int will convert it to 1, and when it is false, it will be converted to 0. What do I mean by that? When I click, I'm already doing the feature engineering, and my in this particular data set, the features are every other thing, but the target is the churn. What the target is what the model will do. The model is to predict if a customer churned or not. So that means in this case, my target is this thing. This is the target. The target is this churn. That's the target. Now every other thing here are the features. The target is churn. Okay. So already I'm working on the churn. Yes, I want to work on it. It's part of, although it's the target, but I'll be training the model with it. So I need to work on it as well. So df.churn will go to the churn column, and then df.churn equals to yes. We'll go ahead and is it as I explained there, if the boolean corresponds to yes, so it goes to the churn. Is the churn there yes? So if it is yes, it's going to convert it to 1. But if it is false, that the person did not churn there is no, it's going to convert it to 0. So when I do that and I go ahead to view my data set, you discover that things have changed. We have some changes now. Let me select the first thing. So no 21. So look at it now. Can you see something? So instead of yes, 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 no, 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 we now have 0, 0, 0, 0. Things have changed because of this particular thing. Now here's the next thing I'm going to do immediately after that. I am going to go ahead and split my data. I will split my data from there. So splitting data, there is how what's splitting data all about. Let me show you. Now, if I have this data set, okay, so this is how my data set looks like, and I want to train a machine learning algorithm, I have to get what we call a training set and a test set. The training set is the set you are going to feed into your algorithm at the initial time. The training set will contain the information the algorithm needs to work with, okay, to learn to perform the task you want it to perform. Now, the test set is actually the data set you're going to use to evaluate if the algorithm was well trained. Is it really doing its work? That's the test set. And according to Andrew Ng, you actually need three things. You need a training set, you need a test set, and you need a dev set. I'm going to explain. You need what? Three things according to Andrew Ng: a training set, a dev set, and a test set. So, how do we get the training set and the dev set? The training set, the train set, and dev set, those are the ones you are going to use during your basic model when you are trying to still do your model, like to train the model, to now do the basic parameter tuning, evaluation of the model to see if the model is working fine. That's the train and dev set. Then when you are done with all that, now when you want to now test the model during, okay, before deployment, now you then make use of what we call the final test set. That's like the test set itself. Okay, so why is that important? If you train the model with just everything, all the data set you have, it means you don't really have a data set to evaluate if the model is okay, if the model is actually working. You don't have a data set to do that. So what it ends up, the problem it creates for you is that you don't really know if your model will do well when it is deployed. Okay, when it is made available for humans to use, it might fail. But when you keep a test set, a final test set beside, it means when you are done with your model training, hyperparameter tuning, all of that, your validations and and the likes of them, you can use that particular data set to evaluate the model and discover if this model is doing the right thing or not. Okay, so that's all for today's class on train set and dev set. I'm going to send that book by Andrew Ng. It's Machine Learning and Yearning. I'm going to make it available in the Telegram channel. You can go ahead, download it, and go to the particular chapter where he wrote on dev set and train set. So you have an understanding of what like his own perspective. And by the way, let me show you who Andrew Ng is. Andrew Ng is this person. He's he's a world class. That's him. Okay, so he's like a pioneer in machine learning and on. Okay, the pioneer here. He focuses on machine learning and artificial intelligence. That's part of his works. So back to business, back to working with our train test and all. So currently, I'm about to do this. I'm about to split my data set. So to split data set into train and test data, I'll have to go to sklearn. Now, if you do not have this right now in your Jupyter notebook, you can do pip install scikit-learn. Scikit-learn is this package. This is it. Okay, I'll still teach you that. Scikit-learn is a here's it. It's a very nice package, okay, for machine learning, data science. Yes, it's a free software for machine learning. That's a library for Python programming language. Okay, so if you are really a good number of what you do in supervised learning, we make use of just scikit-learn. Yes, it's a library that contains lots of functions you can make use of. Enough of them, like enough functions, okay, for machine learning, data science, supervised learning. Scikit-learn is good. So from sklearn, that's an abbreviation of scikit-learn is sklearn dot model selection import train template. Now, when the scikit-learn is a library just the way you have a library and there are lots of books in the library. So now in this scikit-learn, it has lots of functions for model development. So if I go to sklearn and go to the model selection, from there we import the train template. So now this train template function, train template is actually a function. So what it's going to do right now is with the train template, I will be able to split my data set, okay, into a training set and a test set. In the past, before scikit-learn, a data scientist will have to do this thing manually. Yes, but right now with train template, you can just use it to split it. So here I created two variables, df underscore train underscore full, and then df underscore test. So I will equate it to train template. Now the first thing parameter I'm feeding in, or like an argument now into the train template function, is the data set itself, and then followed by the test size. What does this 0.2 test size do? It's going to cut the data set, okay, in a way that 0.8 will be the df train full, and then the 0.2 is going to be for the test. It means 20% for testing the data set, the model, and then 80% for training the model. I don't know if you understand. Test size 0.2, that's 20%. 20% is the test size. That means the remaining percentage, which is 0.8, and that's 80%. That's the training set. So it's going to just cut this thing into that. And now random state 1. Why did I tag random state to be 1? It's just to make it reproducible. If I don't put random state as 1, if I run this program, it's possible that it will not really pick the train set and test set in a certain order. It might change the order it's picking it. But when I fix it to 1, it must respect a certain pattern, like it will have an order. Okay, it means even if I give you this code and you run exactly what I do, you will have the same answer. But if this random state is not 1, there's a possibility that your test set and your full set will, it's going to give the same shape, okay, the same information, but then what you'll find in those different data sets for the both of us will vary. So to make it more reproducible, we choose the random states to be 1. Now let's have the next thing. So I'm going to run it now. Now I've done that already. So next thing I'm going to do it, I need to, having split the, so from for what I explained in the beginning, we have this test set is for the final testing. Now my df train full, okay, that's that one for training. I also need to split it into a train and a test. That's a validation. So I mentioned 3 things in the beginning. So let it not be as if I'm getting everything mixed up. I mentioned a training set, a train set, a dev set, and a test set. This is a test set. Now, this DF train full, that's the one I'm splitting into two, into train and validation. The validation is same thing as the dev set. When I say validation set, that's the same thing as the dev set. Okay, they are just the same thing. So now I'm splitting that DF train full into DF train and DF val. Let me use Excalibur to show you what I mean. It means that I have this, the DF train full, okay? I will then split it into 2, okay? And now this is the DF train, that's data frame for train, and then the data frame for test. So, okay, let me erase this. Validation, that's validation. So the DF train and the DF val, that's what I'm going to use all through the stage of model training, parameter tuning, model evaluation. I'm going to make use of df train, df val. When I'm done and I feel my model is now okay, I will then test it on the final test data. That's just the goal. If I do not do that, I will not really be okay. I might not really properly evaluate if that particular model is okay, if it is okay enough, because maybe the data set is all the data sets I have in the world. I don't need to throw in everything one at a time. I need to keep those things, okay? Like use the one you can use now and then make use of the remaining last, so that you don't mess up the algorithm with all the data. So that's the reason for that. Having done that, I will go ahead and run this and then I will explain. So what's going to do here, I believe you figured it out already. If you look now, the data set is now df train full. Now the test size is 0.33. Actually, Andrew Ng recommended 0.30. That's 30% for your for this kind of software, as for the validation or something. Think yes, he recommended something like that. But here we're making use of 0.33. What's going to do now is this: 33% of the data of the train full data, that's df underscore train.full, 33% of it will be the validation data set. And then the remaining percentage, which is that 67, will then be for what? The train. Do you understand? And I hope that's clear enough. I hope that's clear enough. So if you've done that, look at the last thing we are going to do. Here's the last thing we're going to do before going further. The last thing we're going to do is this. We need our y and x. So what's that? The y train, it's the churn values in the train data set, and the y var refers to the churn values in the validation data set. Let me explain one more time. As I said in the beginning, the if you know about a simple equation, y is equals to 2x plus 1. In this particular equation, the independent variable is x, and now the dependent variable is y. It means that the outcome, which is y, the outcome is dependent on x. So x are the features, y is actually the outcome. Now the outcome in this case is, did the customer churn or not? So it means that that part of the column of the data set that's churn, yes, no, that's our outcome. That's the outcome. So we need to bring it out. That's what we're going to classify as the y values, is the outcome we want to predict. So we'll bring them out. Now x refers to every other feature that is relevant to predict this outcome. Every feature that is relevant to predict this particular expected outcome, that is x. So what we are doing right here is just to bring out the outcome. So in the first case, the first scenario is this: we are going to use the features and the y train to train the model. And then the next thing we are going to do is we're going to validate the predicted value of, we're going to now use the model to predict values. So the next step is to use the validation data set, okay, all the features, put it run it through the model and see if the model will be able to predict exactly or near to what we have in yval. Am I clear enough? I hope I'm clear enough. So we use the y train and all the features to train the model, and then we try to now use the features in the validation data set, okay, to see if the model, the predictions from the model, will match what we have as the y val, okay, in the validation data set. So now why am I putting del? So del is delete. So what I'm doing there right now is, when I say del df train churn, it means that after creating this thing, after creating these new values, that's assigning churn in df train to y train, and then assigning churn in df val to y val, I want to go ahead and delete those values from the data set. When I do that, automatically everything remaining in the data set turns to the features, and then this y train and y val becomes what? The target. So let me show you what I've done now. So if I do this, you discover that I no longer have churn in this data set. I just deleted it. But then if I want to find that churn, it's now in the Y train. So let's do this. Good. So the Y train is now an array that contains those values I had here before deleting it. And if I go for Y val, so that's same thing. So it now has those values, okay? It now has the values I removed from that particular table. So let's take the next step. Now the next step is this. The next step is just to do a minor exploratory. Okay. Um, how many? So I have just 30 minutes to finish up. So let me be faster now. Now here's the next step. The next step, what I'm going to do next is just to the next thing I need to do is to perform a small exploratory data analysis right here. That's the next thing I should actually do, and I'm just going to do that right now. Um, so now if you look at this thing, you can see that I have df trained for churn values. So I have number of, well, if it's zero, it means it didn't churn. Then if it is one, it means it churned. So if you look at this carefully, you see that I have 4,122 clients that did not churn, and then 1,500 clients that churned. The number of churn and did not churn, it's not balanced. So this particular information right now helps me to understand that my data set is not balanced. It has a class imbalance problem. The next class in this particular series is about handling class imbalance, actually. But before that, it might be good to give you an overview of what class imbalance is. I think I have, yes, I have a document on that here. So what is class imbalance problem? It is a problem in machine learning where the total number of a class of data, that's the positive, is far less than the total number of another class of data, negative. This problem is extremely common in practice and can be observed in various disciplines, including fraud detection, anomaly detection, medical diagnosis, oil spillage, facial recognition. So Why is it a problem? Most machine learning algorithms, they work best when the number of instances of each class are roughly equal. When the number of instances of one class far exceeds the other, problems arise. Okay, that's just it. So I don't know if it is clear enough. So if you look at what I have here right now, you see that I have 0, 4, 1, 2, 2, and then so those that did not churn 4,122, those that churned 1,503. It's not balanced. Something needs to be done about this. I need to see a way of making things balanced. Okay. So to further facilitate that, um, why this class is not about handling class imbalance, I will show you how we are going to deal with this problem later on in the video. So just continue watching this video. I will handle it a bit in this particular class, and then in the next class on handling class imbalance problems, I will really give you a deep insight on how to handle it using two basic methods. You either the model approach or the data approach. This so I have this. So So what did I just do and why did I do that? So I want to calculate what we call the churn rate. So I want to understand the rate of churn, okay, in that data set. So when I type global mean df train full dot churn dot mean, so what's going to do right now is it's going to go to this thing, that df train full data set, and select all the churns. Like when the customer churned, it's going to go ahead to get the mean. Now, what is mean? This is the reason why we learn statistics in machine learning, because some of these particular terms keep coming up, like mean, standard deviation, um, yes, mean, the standard deviation, and some of those terms like that. Even some other terms that I would like to mention right now. There are higher statistical terms that come up, but let's just focus on the basic one, which is mean. So what's this thing all about? Since I have the churn as 0, 1, 0, 1, 0, 1, and so on and so forth, what's going to happen right now is just this. Uh, the How do we calculate mean? How we calculate mean is, for example, if you have a set of values, like let's say you have a set of values like 1, 1, 2, 3, 5, 7, and you're asked to get the mean of these values. What you need to do is that you need to add all of them up. If I'm correct, you add all of them up, and then you 1, 2, 3, 4, 5, 6. You add all of them up and you divide by the numbers you have here. So if I have six numbers, I'll add everything. 1 plus 1, 2 plus 2, 4 plus 3, 7 plus 5, that's 12 plus 7, that's 19. You divide everything by 6. When you must have done that, that means you're going to get the mean. Now let's get back to our data. In that chunk column for our data, we have only zeros and ones. So if I'm looking for the mean, what's going to happen then is that it's going to add just the ones, right? Zero is nothing. So 0 plus 0 is still 0. But it's going to add up all the ones there and divide by the total number of occurrence. When I do that, I will have that the mean of churn here is actually 0.267. So that mean is what we call the churn rate. If you are confused about what churn rate is, let's check churn rate here. Churn rate. That's a percentage of customers lost, okay, over the course of a month. To calculate monthly churn rate, divide the number of customers you lost over the month by the number of customers you had at the beginning multiply the results by 100. So when I add all those that are churned, okay, those are churned by the number of customers I had at the beginning, multiply by 100, you get the churn rate. So that's just what I did. If I calculate the global mean using that method, okay, I will get exactly the churn rate. So this tells me the number of customers that left my service. In this case, 26.7% of the customers left. It means actually the number of customers that left the service, that actually it's low, right? It's not that high. But even at that, they have a business value, right? So because of that business value, it's important to develop a churn prediction model so we can actually retain these customers and maximize profit. So next we're going to do right now, it's we are pretty much getting into a a, a better part of the feature engineering and model development. And now this. So what am I doing right here? I want to create um now this num codes is now a variable. So the variable will contain list. Now what do we have in that list? Tenor, monthly charge, total charge. So I want to get all the columns containing numerical data and set it aside. So because of that, I'll create that. The next is this. Right now, I'll just do more of copy and paste because of time. The next is categorical columns. So you can see all the columns containing categorical data. I have them set aside, that's separate. And then I will go ahead and do this. So what am I trying to do here? I want to know the unique number of unique data we have in each column. So in the gender column, we have just two unique data, male and female. In senior citizens, just yes or no. Partner, yes or no. Dependent, just two types of unique data. Now, when we go to online security, we have more than one. That's three. We go to online service, streaming TV, the likes of them, payment method, four unique data. So this is going to help me understand why am I doing this. It's going to determine the type of this thing, feature engineering I'm going to do on those categorical data. Okay, what I'm doing now is I'm building a step towards feature engineering for categorical data. That's why I'm doing that. Now let's continue faster. So I am going to terminate the now because of time. I'm going to stop the live stream at this. I'm going to stop this class right here because of time. So I'm going to take a little break. And I believe if you're a beginner, it's a whole lot. But then if you're not a beginner, this is nothing. It's like, come on, these basics. But then if you're actually a beginner, we've done a whole lot. Okay. So I will stop this video at this point and let's take a little break. So I'm going to create a part two of the first class, which I'll make available this week. And I believe it's going to be a starting point. So let's say you take some time, go through the resources I have on the Telegram channel. You can watch this video also and get started. The next class will be better and we're going to dive more into details. I don't want to rush things, so I want to be more detailed. So because of that, I'll cut the class right here. So thank you for watching whenever you get to watch this video and see you in the next class. Oh, okay.